Wonderful. So I welcome everyone. Welcome to Art Laboratory Berlin. Welcome to the online workshop. It is a design-driven workshop. My name is Regina Rapp. I'm meeting you today virtually from our Art Laboratory Berlin office in Kreuzberg. And I want to welcome you to meet Farah Peluso, who is with us today virtually from the Art Laboratory Berlin space in Berlin-Wedding. And we have very interesting guests. And I also want to introduce you to our colleagues, the biotechnologists, Bertram Schmidt and Kustrim Cherimi, who are with us here in the Zoom. And they will also present their ongoing workshop about our common project. And this is why we are here, Mind the Fungi. Mind the Fungi is now for about 1.5 years ongoing. It's a collaborative project between the Institute of Biotechnology of the Technical University in Berlin and Art Laboratory Berlin. It is an art science project, and it very much is interested in using fungal material as a substantial material for the future. And our task from Art Laboratory Berlin is to bring science and art together, and also to become active in the citizen science section. And so here we have Farah as an artist in resident, as a designer in resident for a 2-year project period at the Mind the Fungi project. Let me quickly give a tiny introduction into as far as a background before I give you a little bit of an idea of our scheduling for this online workshop today. Farah is very well known to Art Laboratory Berlin because we have worked for her for quite some time. She was an artist present in our group exhibition Watery Ecologies. She's also not only an artist and design member in Mind the Fungi, but also in our art science group DIY Hack the Punke. And first of all, we can say she's coming from Rome, where she graduated in industrial design and graphic design in the University of La Sapienza. And so she has a background of art and design. And her main focus is going to speculative research. And in her work, she wants to connect the human being with nature, living organisms, and biological processes to form a deeper relationship. Her collaborative interest is always there. And I think we also see this here in Mind the Fungi, because she wants to work together. And in our case, it's with the biotechnologists. And she also has worked with biologists. And she has pursued deep research into algae. So algae is, I think, her leitmotivic material. And we will learn today also about algae and fungi. She's taking constantly inspiration from algae. She is experimenting with algae. And she wants to understand how to work with them inside the fields of art and design. And in collaboration with BioArt laboratories in Eindhoven in the Netherlands, she developed prototyping of a speculative wearable accessory. It's called WeReactor. And this connected the algae's photosynthetic process with the breath of wearer. So you see already, this is a little bit the intersection of biology, biotechnology, design, and speculation. And Farah also has extended this knowledge over the last 15 months by working with researchers at the Technical University in Berlin, as I said, at the Institute of Biotechnology. And there are 2 departments. There's the Department of Bioprocessing, but there's then also the Department of Molecular and Applied Microbiology. And this is actually where we have our colleagues with us today, and where Farah intensively worked and experimented for the last 1.5 years. So we're very happy to have you all with us. I will mute myself in a little while. Let me just quickly tell you the timing that we thought of our next 2 hours. Farah will quickly introduce herself. Then we would like to invite our colleagues, the biotechnologists, to speak. Bertram and Kustrim will update us each 10 minutes with their scientific research in context of Mind the Fungi. Then Farah will give us a very thorough insight, about half an hour into her design research. And then afterwards, we have the possibility with Farah to look at her samples, at her design samples, and she will show this with a second camera she has embedded in Zoom today. And then finally is the chance for the participants here in our Zoom round to put questions, to come and approach from your background, to interrogate, or also to share with us your ideas. I think it's also important today that we learn from Farah, but since Farah is at the moment in her design research and also in preparation for more projects for Mind the Fungi, I think it's also important that we share our ideas with her, and as we come all from different angles, that it's probably also useful as a sort of a working period to share and support her in her research. So this should be actually far more than I wanted to say. So I would like to mute myself and hand over to Farah, and after a couple of minutes then to Bertram and to Kustrin. Thank you for being here with us.
Hi, everybody. Welcome to Material Drawing Workshop, and thank you very much for being interested and curious about this project. Yeah, Regina gave a thank you so much for this beautiful introduction. I'm an Italian artist and designer, so I come from Italy and I'm based in Berlin since 2014. And as Regina already said, I come from an industrial design education. But I always wanted to have an experimental and speculative approach of the design field, because I didn't want to just contribute to the production of simple object and just for, let's say, produce object for human being needs, but the reason I wanted to start with work with the speculative methodologies, because I wanted to create something that it's more for a whole system where not only human being has the main part, but where also the other organisms in relationship with human beings. So then, for this reason, I started to research in biology and involve art in my design practice, and I started to work. The living organism I started to work with are the algae. I will show you quickly later after the contribution of Bertram and Kustrin, what I've developed already with algae, and then I will show you more deeper my artistic and design research for Mind the Fungi. But I want also to tell you quickly that this collaboration between me, art laboratory, and the two TU scientists, I mean, it's something very important. It's not just a simple collaboration. I want to say that we constantly, mostly every day, every week, we meet in the same space, in the same environment, which, I mean, okay, for the scientists, it's a daily working environment, but for me, I mean, I'm talking about the laboratory of the microbiology department. So for me, was still something new. Because I've learned how to work with microorganisms. I received from them some scientific knowledge, and but thinking and questioning from a design and artistic perspective. So in this way, we really share our tools and knowledge, and also our way to pose questions. No, so this, and yeah, and then I want to tell you also that my contribute for the Mind the Fungi project, my research is mainly focused on a material design research. So I'm still working understand how to use the mycelium to produce a new organic material, and a biofilm, so a new textile. And yeah, and then later I will show you my methodology, my process. So thank you again. And yeah, I think now I can, yeah, Bertram can maybe start, and then I will.
Oh, can you hear me now? Yeah. Okay, I will share my presentation with you. 1 second. Can you see it? Yeah, okay. Okay, yeah. Yeah, of course, today Farah's material science is in the center, but she asked me to give a little introduction about our fungi and why we are working with them. And she also asked me to be a little bit, go a little bit into detail what mycelium is, because maybe it's not clear to all of you. And I also want to give you some impression of our collection of fungi. And yeah, let's start. So, you know, the kingdom of fungi is very big, and there are many different groups in it, and there are many different ways to divide it into subgroups. Some are, of course, following finally how closely they are related or not, but there are also technical ways to divide the fungi world. For example, in yeasts, molds, and higher fungi, it's more a technical view, because all of those groups are very important. Those groups are used widely and also cause problems. For example, yeasts can be pathogenic in some ways, but also play a huge role in food technology, for example, yeah, brewery, bakery, and so on, fermentation. And molds are the same. They are, of course, you know, molds maybe from your room. If they form spores, you have a big problem. But also molds are used widely in biotechnology. For example, you use aspergillus to produce citric acid. And we are working with a higher fungi. Can you see my mouse arrow also? Okay, then I can, yeah. Perfect. The fungi, for example, here's a fruiting body. And yeah, they are, of course, you know them from the supermarket. You can buy them put them on your pizza or whatever. But also they have some problems, or they can cause some problems since they degrade wood. They also kill trees sometimes. But that's the group we are working with. And if you go to the forest, you can see many different fruiting bodies, and they are very beautiful. So we also do trips to make photos, and some you can eat. For example, the halimash here. And one of the most common wood-degrading fungi is the Fomus fomentarius, the Zunderschwamm, tinder mushroom, and it's very common. But we have a big collection of fungi in our project, but still we found out that that fungus is one of our workhorses and very important for our technology. But Farah is working with oyster mushroom, I think, today. And yeah, but that's just the fruiting bodies of the fungus. And I think many of you know that not the whole body of the fungus is that thing. It's just like the apple to the apple tree. So you can see those fruiting bodies. But when we are talking about fungi and working with them and using them in biotechnology, we are talking about mycelium. So if you take a dead tree like this and remove the bark, you may see something like that, like big strands of white stuff. And that's the mycelium. That's the normal way that fungi live, and the active form of fungi. And that mycelium is on the edge from macrobiology to microbiology. So we are microbiologists, so we are allowed to work with fungi because one single hyphae of them is very small. You won't see it. You just can see big bundles of hyphae, and the whole sum of hyphae is the mycelium. And of course, also the fruiting body consists of mycelium, but it's more specialized. And we are working with that state of living of the fungi. And it's the active form. It's how they degrade their substrate, how they conquer new space for living, how they communicate with bacteria, with other fungi, with plants. And that's how they degrade substrates, how they build up their own biomass. And the fruiting body is just one kind of organ or pseudo organ with which they use to form their spores. And yeah, and one way that mycelium is important is they can get in contact with plant roots and form those mycorrhiza symbiosis. It's well known to many of you, I think. I won't go into detail here, but it's as I said, fungi are very important in many ways, and one is forming symbiosis. Yeah, but we wanted to work with wood-degrading fungi, so we did some sampling and isolation, and I won't explain it in all the detail today, but we collected the fruiting bodies of the fungi. That's why we need the eggs, and we also collected some edible mushrooms, by the way. And our aim was isolation, so bring them into pure culture. And that's one graphic I made some weeks ago for a book project, which should represent our strain collection. So we visited many different forests and collected many samples and isolated many of the fungi. And most of them are in the group of Polyporales, which is the normal tree mushrooms. And some others are agaricales, which is more like similar to champignons, the normal mushroom with stem and umbrella. And one is an ascomycete. Those are all basidiomycetes, and that's Xylaria hypoxylon. That's a nice example. I will show you later some more pictures. And we have more than 60 strains in our collection. And I already mentioned several times about pure cultures. So that's how we cultivate the fungi. It's on agar plates, and it's different strains of fungi, and you can see some differences. That's the oyster mushroom, for example. And if you work with them for months, you will be able to recognize them by morphology of the colonies. Those colonies are now 1 week old, growing on malt extract agar, and that's how we cultivate our fungi in the strain collection, how we control that they are pure, that no bacteria or molds are entering the cultures, and that's the most controlled state of our lab cultivation of the fungi. And yeah, that may also happen when we try to isolate the tree fungi or the wood degrading fungi. You very often ended up with molds, and the difference is in a raw description that the basidiomycetes can only form spores if they form fruiting bodies in most cases, and the molds are forming spores on microscopic fruiting bodies, and they form huge amounts of spores, and that makes them problematic. So they are also useful for other applications, but for our materials, we didn't want to use molds because we don't want to produce a biomaterial which produces spores which may harm people's health. And yeah, but it happened very often that we isolated molds because it's not so easy to get a sample where no mold spores are in. Okay. Another example, so we also grow the mycelium in the lab on solid substrates, it's straw. Kushtin will talk later about this more in detail because it's already into the material science scene, because it's a kind of composite of fungus as a glue and solid substrates. But it's also interesting solid state lab cultivation. And if you zoom in a little further with a macro lens, you see that the mycelium is still that spider web-like stuff. One interesting example here, Xylaria hypoxylon, candlestick fungus, as I read in the internet. And it's a very nice fungus. It's the only ascomycete we have in our collection. And interesting thing is it has very small fruiting body, so it was very difficult to isolate it. but it worked finally, and interesting that they formed a fruiting body also on the agar plate. And you're starting to form those little horns, which will develop into those stack horn-like shapes. And that's the oyster mushroom, one fungus that Farah is using for her experiments. And it's edible. You can buy it in the supermarket. Also, the one we have in our strain collection is one that I found near Potsdam on a bike trip 2 years ago, and it looks very nice and like snow on an agar plate. And also here, if you make like material samples and don't dry them, it shows again that it's still a fungus and is still able to not only grow as a mycelium, but also forms fruiting bodies which you could eat. Yeah. Okay, that was my part, and I would stop the thing and hand over to Kustrim. Okay.
Now, can you hear me? Hi. Okay, hello everybody. My name is Kustrim, and as you can see, I'm wearing a Mycelium bicycle helmet. But before I came to this interesting stuff, I will tell you some technical things, some boring stuff from my master thesis. And yeah, I will also share my screen right now. Okay, so, okay, let's go. Come on. Okay, so I worked in the Fungi lab for 6 months, but I started working with funguses or mycelium and at home 1 year ago. And yeah, I did my master thesis there, and also I'm currently doing some other projects like working on this book publication together with Bertram and Carsten and the team from the ALB and Farah, of course. And yeah, I would just tell you at the beginning something about my master thesis, which is quite like technical and doesn't really have to do, well, it has to do something with the fungus, obviously. And yeah, if you have some questions, just, yeah, feel free to ask me after that. So Bertram told you something about these plates where we tried to grow the fungus on pure culture on these plates. And one thing that I was wondering is how can we evaluate or quantify the growth of these myceliums on a growth plate. It all started on the left side with a photo made by a smartphone, or you can also do it with a camera, with a good camera. And then I developed a processing pipeline in Fiji Image, which is an image processing program, just to measure this area like properly. And then I also defined something like the flat mycelium, mycelial growth in the core region, and this was the aim of this pipeline was just to measure this after, like, for example, 6 days, and to tell you something about the growth speed and the growth area that the mycelium is able to cover over this plate, with the background that I also wanted to test different substrates to make sure, okay, is the mycelium able to degrade glucose instead of lactose, for example. And then I had this pipeline just to quantify this assumption. Another thing was that you can use also the CO2 as a growth indicator, because the mycelium also takes O2 inside of its mycelium or inside of the fruiting bodies and exhales CO2, which means the more CO2 can be measured, the higher the growth or the growth speed. And for this purpose, I just built an Arduino-based measurement system, which is based on a microcontroller from China. And yeah, the data that is obtained there is the CO2 and the humidity, and also the temperature. And yeah, and the outcome is a script, a Python script or a plot, which shows you, like, after, for example, 8 hours, how the mycelium exhales CO2, how the temperature, like in the incubator, well, the temperature key is constant because this one is placed in the incubator, obviously, so the temperature is always 27.5 degree, but the humidity, for example, also can change. And as I said before, the CO2, which means if I take a look at the CO2 concentration after 3 weeks or something, I can tell definitely that the mycelium is not growing anymore, or is like in an exponential growth phase or something. And this was also like a part of my work there. And yeah, I started also doing a lot of I read a lot of paper, because we didn't really know that our favorite fungus, Fomus fermentarius, also the tinder mushroom, is not like the research background is not that good. So we started to check whether it's able to use specific carbon sources like mannose, glucose, maltose, sorbitol, and dextran. And we also wanted to know which kind of nitrogen source this fungus need, because obviously the fungus which is like taken from the woods grows pretty good on a complex media, as it is the same for other microorganisms like yeasts or other molds like ascomycete or basidiomycetes. But the very interesting question is, how can we define a specific growth medium, or as we call it, a minimal medium, which where we know the exact composition, and then we can change different parameters to check if the mycelium or if the fungus is able to produce asparagine, for example, or is it not able to do so, and stuff like that. So yeah, I just checked it for the carbon source, for example, and I checked it with the pipeline on the left side, and you can see here that the mycelium grows pretty well in complex medium, as I said before, and it really likes like sorbitol or maltose, but it didn't really like glucose, which is kind of new, because glucose is like the standard carbon source for different kind of organisms, and it's also something that human like, you know. And so yeah, this is just one very early like result of this thing, and I will keep on studying the mycelium. But then Corona came, so I have to finish all the stuff at home. Okay, so this is basically like the boring technical stuff, but I also would like to show you some products that we made in the lab together with Bertram and with Bastian, which is not here today. And yeah, I will start with this wonderful mycelium helmet that I showed you before, which we did together with Bastian. Bastian is a bachelor student there, and the basic idea is that you take the raw substrate and inoculate the substrate in a growth bag. The growth bag looks usually like this. I hope you can see it very good. And this growth bag contains these zebra stripes, which is the reason why it's called zebra bag. And yeah, the mycelium is grown in these bags, and then it's broken into smaller pieces and put into a scaffold or mold, and then you can create something like this, which is like supposed to be a bicycle helmet. Not really complete, but yeah, at least it looks like a bicycle helmet. This was part of the bachelor thesis of Bertram, no, of Bastian, of course. And yeah, we also are working together with different architects and with Sven Pfeiffer.
I'm sorry, Costume. You're still sharing your presentation with us. We don't see the helmet. Or did you stop it? Now I see the stuff. But
oh my god. Okay, I thought you could.
Now I see you. It's okay.
Wait. Ah, okay. So nobody has seen the helmet?
We can see you.
Then
both of them. We have both.
What about the helmet? Have you seen the helmet?
Both of them, your screen and also you.
Okay, cool. I only saw the presentation. Sorry.
Okay, for Bertram again, this is the helmet, but you know the helmet. And again, this is like the growth bag. This is an older growth bag, which gets these dark areas somewhere. I think this growth bag is around 3 or 4 months old. And yeah, we also work together with different architects. And for this, we developed some bricks, some mycelium bricks, which looked like this. And this has the specific design that it fits to another part, like which looks like this. And then you can, or this follows the idea that you can basically build a house with mycelium or with these mycelium bricks. Okay, and yeah. And this is also something which is a part of the bachelor thesis of Bastian, like the helmet. This is a specific cylindric form which is used to test different parameters, different material parameters of the mycelium composite. So there are these complicated machines which are like pressing the mycelium together this way, or which are tested how much like strength is needed to break this mycelium cylindric form into two pieces, or maybe not to break it into two pieces. So yeah, that's basically what we are doing in the lab. And yeah, that's basically from my side. If you have any questions, then you feel free to ask me then. And yeah, thank you. Okay.
I don't know. I think maybe for the question we can do later, no?
Yeah. Okay. Cool.
Okay. We do all the question later.
Okay. Perfect.
Yeah. Thank you so much. Thank you very much.
Thank you. Nice to meet you. I will close my video, but
okay. No problem. Yeah. Thank you so much, Bertram and Kushrim for your presentation. Now I'm going to share mine. Let's see. Okay, can you see? Perfect. I want to put this here. Okay, so yeah, my artistic design research for my the Fungi project started the project started in 2018, but my my work in the lab started 1 year ago, actually, almost. No, more than 1 year ago, and I've developed several experiments, and constantly all my experiment always has been a constant topic, which was the coexistence topic, and but I will tell you later why. First, I would like just to give you a short introduction about my work with algae and the speculative design. These are two projects I developed in 2016 and 2017, and they are both about speculative variable accessory. And the idea behind this project is to question what if in the next future we will be able to wear an accessory which is also connected with our breed, and which also is able to grow some algae also thanks to our breed. So basically the idea of this project is to have a new kind of tool that can use our breed as CO2, and at the same time we can transport algae, you know, like here in this example, we can transport algae with us, feed the algae with our breed, with our CO2, and but receive oxygen back. So this is an example of possible, let's say, symbiotic relationship we could have with this organism, and also something that can also contribute to change our opinion that we have about this microorganism, because they are one of the most important organisms on Earth, producing most of the oxygen we breathe every day. This is one of my last projects I developed last year for a residency. I started to research also about a climate change phenomenon which is connected with algae, which is called algae bloom, and it's a phenomenon that it's connected also with the human being activity. Basically, this is an installation that recreates a kind of water ecosystem scenario when the lakes and the sea are polluted by chemical waste product from human being activities, and I wanted to recreate this scenario, and also play with the algae pigments and see how these pigments can change color in the time by time. For my research from my Mind the Fungi project, as I told you, so I've been working mostly with Bertram, with Karsten, which is also one of our collaborator, and in the microbiology department. And so far I've been able to develop this biofilm, which is mycelium based, but it's also combined with some algae powder, algae material. The reason why I wanted to explore this topic of coexistence is because in nature there's an interesting relationship that some fungi has with algae in a form of lichen. So I don't know if some of you knows that the existence of this organism, which is called lichen, and the lichen is basically another organism which is the result of symbiotic relationship between fungi and algae. So because I come from let's say algae knowledge, and I wanted to combine also both of the research. The two main experiment I developed for Mind the Fungi are the housing mycelium and the mycelium leather film. The housing mycelium was basically, I wanted to investigate how the mycelium behave in connection with other fabrics. I've used natural fabrics like cotton, but also I will show you later also some synthetic fabric. And I've combined the mycelium cultivation, the mycelium culture together with the fabric in the same environment. And in the mycelium leather, it's basically I started to grow the mycelium from a liquid culture, so which is something quite similar to what Bertram already showed. So it's not petri dishes with agar solid culture, but the mycelium here has been cultivated from a liquid culture, which basically is the nutrient that the mycelium needs to grow. So here, this is the housing mycelium experiment. So I started with growing the mycelium with petri dishes to get the knowledge, the scientific knowledge, but then I wanted to move this with scientific process, scientific methodology into another way. So we wanted to experiment and to see how the mycelium is able to grow inside another in a different container, let's say, and we experiment with some simple plastic boxes from the shop to see how the mycelium can grow, like homogenic or not, how thin, and how it behaves with other fabric. So in this example, you see on the right side, on the bottom, you see the result of my experiment. So the mycelium being the behavior of the mycelium was quite interesting, and look that he likes a lot to live together with this cotton material. And these are some pictures from the experiment I've just shown you. These are some pictures I took under microscope to watch more deeply, more close, the connection of the mycelium with the meshes of the cotton. And yeah, here, for example, on the right, on the bottom, we can see that Mycelium has not been really able to grow through the mesh because the mesh was too small. But if you use a mesh bigger, then you can see how the mycelium can go through it, no, and really have a kind of coexistence. Then I wanted also to experiment with other fabric, like synthetic, like the polyester, the polyurethane, and also the Utah also is an organic fabric. And see how the different shapes of this material can be interesting, and watching, you know, the behavior of the mycelium. So what you see on the left, it's basically is the same experiment with the same material, but with 3 different type of mycelium, 3 different type of fungi. And it's interesting to see how not every kind of species, not every kind of mycelium react at the same way. So this also was quite useful for me in the beginning to understand with which kind of mycelium, which kind of strain I have to work for my research. Then I at the same time, not later, but mostly at the same time, I started to produce the biomass, the mycelium biomass from the liquid culture, and see really from the early stage, understand what means mycelium, what are the characteristics, the future of a pure mycelium, and what can I do later to improve the future, the characteristic of the biomass mycelium. Also in this case, I started with 5 different strains, which means 5 different fungus. But then at the end, as you can see, after 2 weeks, I wasn't able to receive the same result from each from all the species, and only 2 species gave me, let's say, results that I was interested to have, and the oyster mushroom, for me, since the beginning, it's always interesting because it grows so fast and give a quite interesting layer of biomass. So already from the beginning, I understood that this was interesting and good for me, and also because I also understood that maybe with oyster mushroom it's also interesting to work because as Bertram said, it's an edible fungus, so we can really apply a DIY approach if we learn how to grow the mycelium, for example, at home. And this is also something that I'm still developing, for example, here at the lab. So how to grow in a DIY, with a DIY protocol and a DIY methodology, a mycelium. After harvesting this mycelium, I noticed that there was, let's say, some problems because the mycelium was too fragile, and I needed to understand how to improve this biomass. Then I wanted to try to produce a powder from this material, because basically is also something that I'm doing with algae, and I will show you better later. So I wanted to do, let's say, a kind of step back, destroy, let's say, the mycelium, dry and destroy, and get a pure pounder of this organism, and understand how to improve, how to improve this material combining with other elements. One of my research projects connected with algae, it's also the algae-based material. So since 2017, I developed this project and I researched how to produce bioplastic with some pounders extracted from algae, and these pounders are the agar, and the diatomite. And because I told you already that the topic I'm interested to develop for the Fungi project is this coexistence topic, then I wanted to implement this topic also into my in this material research, and I wanted to combine the mycelium pounder with the algae pounder combined together and see which kind of result was possible to have. What you see here, it's still what the result from my algae-based material research, and this is a biofilm, algae-based biofilm. And it's basically the combination of agar, diatomite, glycerin, and water. And from this, so the and see what was possible to obtain. From a liquid culture and the boxes, and then I harvest this this piece of biomass, and then I let it dry, and then I create a pounder. This pounder, then I mix this pounder with maybe I can go a bit, yeah, here. Then I mix this. This is the mycelium I dried. And from these phases, I put it into a grinder machine, coffee grinder machine. So as you can see, I work with a quite do-it-yourself approach, and I create a pounder. And from here, I combine the agar, the diatomite, and the mycelium with water and glycerin together. And I cook all this pounder together, and this is basically this is the result that I'm able to obtain. So it's a quite elastic biofilm. It's a quite elastic biofilm, also resistant somehow, but it's not really resistant like the plastic. So what is interesting from this biofilm, it's that it's really a lot elastic. You can fold it, it can keep the shape of you want to give him. And what I want to show you today, it's also how it's possible to create something like this, like a small pocket, and also how to cook this material, and and how to harvest it. So I think that for now I can stop the share of my presentation, or maybe not. I don't know. Okay, I want to show now how I create my material, but I need your assistance, Chris, with the phone. Should I go alone or you can come? Okay. So I work here basically, and yeah, right here. Okay, now I will show you how to produce.
This is right.
Yeah, how to produce a biofilm layer like this.
It seems to have stalled somehow.
Like this, and it's not working. I don't know. Can you see me?
No, it's stalled.
No, we can't see you.
Okay.
Seems to have stalled.
Yes, now a little bit.
Wait. Now.
Now it's on again.
Okay. I think now you can see it, right?
Yes.
Okay, cool. But I need your help. Okay, I will show you how to produce. What's up? Okay. I will show how to produce a biofilm like this. Maybe I can, okay, like this, which is 34 centimeter, which is big, like 34 centimeter for 25. So the receipt I will give you is for this dimension of biofilm. As you can see, it's quite resistant and also elastic. And also something I want to tell you, it's totally waterproof. So this is a test I'm doing since 3-4 weeks, and if you put in the cold water, it doesn't melt, but it's not resistant to the high temperature. So you see, I mean, there are some couple of things I still need to fix. So I will start with the water, and I will put 100 milliliters of water. Here. And then I start to warm up a little bit the water. Then we need diatomite, agar, oyster powders. For each of these powders, we need 3 grams. So 100 milliliter water, 3 grams of diatomite, 3 grams of agar, and 3 grams of mycelium powder. Okay. And then I start to mix, and I wait that everything will melt together. In the meantime, some borax. Borax is a mineral that basically generally we use for glass production, and I wanted to use borax to give more resistance, no more strain to the material, and I put 10 grams of borax. Mix. In the meantime, I prepare the glycerin, and for this quantity, I need 22 milliliter of glycerin. 22 point, yeah, 22, let's say, 22, 23. Then I continue to mix, and I wait that everything will boil, because everything has to be melted. Okay, now it's starting to boil. This. Okay, and then I pour here like this. And then I start to create kind of thin layer. And then I play, because I wait that it will start to dry. And then you will see that it will start also to become a little bit dense. And then I let it dry like this. Basically, I let it dry for 2 to 3 days. Try to create kind of homogenic layer. And after 2-3 days, let's say, this is what you have. So basically, you go on the border, and then you cut this way, no? And then you start to move. Material. And yeah, and this is the final result. This. So then with this material, I create some prototypes. Let's say I made a small bag, and this is a new experiment I'm doing. This is a plant pottery, but I have to repeat it because I have some holes here. And here, for example, I made some small sculpture architecture prototype and show how can we use this material for facade maybe, or for covering, because as I told you, this can be, it's a waterproof material, no? Maybe we can also use for architecture application. And this is just sampling, like can be a bracelet or something, yeah, similar to. Okay, now I want to show you quickly how I made this small model of pocket. Yeah, here you can see it's going to be more solid, no? And then you can already see how the biofilm is going to create. Okay. Maybe you can come here. No. Maybe here. Yeah, exactly. So basically, I'm going to cut this template and find so basically what I've done, I cut it the border from the material, and I took a piece, and then I draw the shape, no, on this material. Exactly, you could do with the paper. It's not so different. So then you should start to press constantly where you want to fold the material, because in the beginning it's a little bit hard, but if you go constantly pressing where you want to fold, you see that material, when the material needs to be dry, totally dry, otherwise it will crack. And yeah, then when it's totally dry, then you see that when you fold it, then it starts to keep the shape that you want to give. And yeah, and then to close it, I use these clips, and then I put it one here. One here. Yeah. And then here. Okay. And that's it. So this can be an example of my food. Maybe I can take just another example. Finish. Okay, no, finish. Okay, so this is how I create the bioplastic textile. If you have there are more questions. Mute my audio. Cool. There are many questions.
Hi, Farah.
Yeah.
Can you hear me?
Yes. Wait a second, because I have to move. Okay, I can hear you.
Okay, so it's Valentina here. Thank you very much for this instance, for the workshop. I think it's very interesting what you're doing and researching. And I have some doubts about, from what we know, borax is toxic in certain amounts. So are you thinking, or what are you thinking to do with this material, or what could be the application of these materials? Maybe I'm wrong, but this is from what I know.
Yeah,
so.
the borax is used also for food, actually, as a medical application to reinforce the bones. So the idea for me is to use this textile for some accessories, so like bags, but for the moment I also want to use it for artistic production, like alternative material as plastic, no? Or yeah, as new fabric.
Okay, and another question, a small one related from what I asked, it was, are you also researching about the impact of this materials degradation on the environment? Are you testing those characteristic of this particular material?
Yeah, basically the agar, it's a material that comes from the food industry.
Mm-hmm.
And the diatomite, it's a sediment flour that comes from algae.
Okay. Yes, I know.
And then you have glycerin, which is used for cosmetic reasons, but also for food. And the mycelium. So basically, the impact. It's not super. It's quite eco-friendly, let's say.
Okay.
Only the borax can be the problem, but the borax that I'm using is the one that can be used for food application.
Okay. Thank you.
You're welcome.
Yeah, can I ask you? And Thank you so much for the workshop and all the knowledge from all of three of you, and being so generous about sharing it. And I was wondering when you said this, maybe I didn't quite get it, but the liquid culture you were growing the mycelium in, which kind of medium do you use for growing the mycelium?
The medium. Bertram, can you come to help me, because I don't remember exactly the recipe of the medium. But yeah, we have glucose. No, maybe it's better if Bertram take. Yeah.
I don't have the recipe here, but fungi can use many different organic substrates, and one of the basic media we use is simple malt extract agar, and you can also use it as a liquid medium. So malt extract agar you can buy as a ready mixed stuff from the lab equipment sellers, and it's one of the very basic things. And it was also, when we started with the project, I expected to have more problems with having the right media to grow the fungi, but actually the malt extract agar was working very well. And for the DIY courses we prepared together with Top Lab, for example, and with Art Lab, we tried to develop another medium which is also working in your own kitchen at home, where you can use things that you have at home. And we developed a medium with soy flour, for example, which also worked very well. And yeah, but you can try different organic things. But actually, we do not know in detail which. Farah, you don't?
It was the liquid medium.
Yeah, we have different. We have the F medium, which was one that Fatime developed.
Yeah, this is
contained
the one.
Glucose and some other things. I don't have the recipe.
I can tell you that basically the liquid medium is based of soya, yeast, glucose, and then we have two minerals, I guess. No, we have the potassium, and then we have the magnesium. Right?
Yeah, actually, if you start to develop a medium, you have to start with the bioelements. So what kind of substances does the fungal biomass contain? And it's like main things are carbon, hydrogen, oxygen, nitrogen, kalium, phosphor, and you have to have a source for all of them. And so the best way is to use a complex mixture of something, like malt extract is produced from malt, and malt is grain. So it's germing grain. So it contains a lot of different substances, also nitrogen compounds. And it's good to work with those complex media, but at the end, you do not know what kind of substance the fungus was using. And that was one of the main part of Kustream's master thesis, to develop a defined medium where he do not add like malt extract, but he adds glucose or some other defined chemical compounds. And then we can see which of the compounds the fungus is really using. Because of the complex media, the fungus will use some part that he likes, and the rest he will just leave. And if you want to make detailed tests, what kind of nitrogen source you can use, especially for industrial applications, you don't want to waste a lot of material. You want to give the fungus exactly what it wants. And that's maybe Kustream can go into some details. Like glucose was not used so well, and the complex medium was good, of course. Yeah, but it's a big field. Does it somehow answer your question?
Yeah.
Of course, you can get the recipe if you write me a mail, or write a mail to ArtLab. We can get you the recipes. So we also share our knowledge in DIY courses, and we also got a lot of help and a lot of information from other people. So we are really open to share those things. Yeah.
That's wonderful. Thank you.
You're welcome.
I also just wanted to show you, I'm just doing some DIY with my own fungus.
Nice.
They just started to grow. These are pink oyster mushrooms.
Yeah, it's Rosenseitling in German. Yeah.
Yeah, but in Denmark, there's a company promoting coffee-grown fungus. So you use used coffee to grow the fungi. Yeah.
Nice.
So that's where I got them.
And it's a specific coffee, or you can use
No,
coffee?
they made this sort of holistic company collecting bio coffee from cafes.
Oh, okay.
So they get it as a waste material,
Yeah.
and then they grow fungi in that.
Okay.
And then they make these, I made this myself, but you can buy small boxes with fungi, and then you just put your own coffee grounds day by day, and then it grows.
Mm.
And then the idea with these ones are to sort of grow the mushrooms so you can eat them.
Yeah.
But my idea is to grow the mycelium so I can use it for 3D printing with other materials and stuff like that.
So you have all the ingredients. You have the coffee at home, then you have the fungi, and then you have also the mycelium. So
Yeah.
And now you just need a receipt.
Yeah, well, I think it's really interesting to be able to grow it in other kinds of, especially the liquid growth medium.
Yeah.
It gives a totally different perspective on
Yes.
the possibilities, and
Yes.
that's really interesting.
Yeah. Okay, I guess that's.
I think I wanted to also invite Natalia. I think Natalia has a question, and maybe for our discussion, which is very vivid, and we're all curious what the participants have to say. Could you maybe please tell us your name and your background? We did this before we went live, so maybe also for everyone out there in the world who follows us would be really interesting. Thank you.
Thank you. Yes, my name is Natalia Miodragovic, and background is architecture, also in field in research and experiment. And then for me is interesting not only to work with fungi, but also this kind of network that you are making, like mycelium growing and sharing your knowledge. So now I'm involved in interdisciplinary research, and then I think it's the work that you do. I think it's very, very important, both material-wise, but also in the community forming exercise. Yes. And then, so my question is also in this direction. I want to thank you all for this presentation. And the question was for Farah, because I didn't really understand mycelium powder. It's just mycelium dried like a powder, no?
Exactly. It's basically what you see that I harvest from the liquid culture. So this biomass layer I've been able to grow, and then I dried, and then I produce the powder from this biomass, and then I wanted to work at the same way that I work with the algae powder. Then I wanted to implement now all the powder together and see, how they exist together.
So it's just a powder. There is no live matter inside.
No.
Because you.
Okay.
I just wanted to check. I got it when you cooked it, but then and then actually what you did now was for us fast, but you could do the joining, like welding with another 3 days of material, like when you were joining the thing. You could add some material and weld it in a way, no?
Which material you think?
When you were making a small bag.
Yeah, this one.
Yeah, the seams.
Yeah.
You actually add some liquid and weld it instead of clipping it.
Okay.
Would it join like?
Well, I could maybe. But I could, for example, what I could do, I could maybe add a fresh of this on it, and then it will stick. Yeah, it will stick and it will dry again together. Yes, this also can can work. This is something that I already done, and I've seen that it's also interesting. Yeah, and in this way, I will not need to use, you know, external material. So in this way, I only use the same material. But yeah, exactly. Yeah, this is also.
This is very nice because you call it bioplastic, and plastic usually you can weld.
Yeah.
And then this is why it's interesting, like you said, not to have extra elements.
Yeah, exactly. Definitely. Yeah, thank you.
This is nice. And then if would you involve something in the medium, did you try to put something in the medium?
Yeah, the medium basically, as Bertrand said, that's basically are the nutrient.
No, I mixed up not the medium, but when you cook your, I don't know how you call it.
When I cook the material.
Yeah, you could put something inside and it will be like a net or something, no? To reinforce.
To reinforce, I use the borax.
No, but like some structure maybe. Like a net or something, no?
Yeah.
Textile. You mean the textile?
I'm thinking about big scale. This is why, yeah. Okay.
Yeah, this is something that I've done already, but I have to tell you that I'm interested to work with a very, very thin layer of material. And when I use the textile, it's always a bit tricky because you really have to keep the layer constantly attached in the liquid. You know what I mean? So it's a bit difficult. I've done already, but I have to tell you, I've not been satisfied of this experiment. Yeah, but this is also interesting. Yeah.
Thank you very much. Yeah.
Thank you so much for your contribution.
Very nice.
There are some other questions. Maybe Valentina, right?
Again, I'm sorry.
Okay.
Okay, I don't know if this question goes for you or maybe for Bertrand. It's related about the polymer that you decided to choose or to mix. Why do you use agar-agar, that it's from the algae, but not the chitin from the mycelium? But Biden's both are polymers. So is there any reason for the choice, like technical reason? That's a question.
But you mean for my material, or you mean for the medium?
From the final mix, from the final recipe.
Because basically it's because I wanted to be inspired from the lichen. And lichen, as I say, it's the result of this symbiotic relationship that the fungus has with algae. So, and because I also come from an algae, algae knowledge, algae artistic research on algae, then I wanted to use agar, because agar is a material extracted from algae. So everything is connected because the fungus they have this symbiotic relationship with algae. So I wanted to recreate in a form of material, in another form, this kind of relationship they have.
Okay.
So it's more conceptual, actually.
All right, thank you.
Yeah. Okay. Any more questions? Regina.
Well, I'm always learning more and more with all the presentations from you, Farah, and looking virtually over your shoulder. Thank you so much for today. I would be interested from the material aesthetics point of view, but I'm talking about here from an art theoretical point of view. So I really want to learn more about the material as such. What is your experience now that you experiment with the mixing of algae and fungal material, and to have hard material, liquid, soft, elastic, and ones that you experiment with algae only?
Well, actually, I have new challenge I want to obtain with this material. No, I would like to have something a little bit more resistant. I would like to improve. I mean, I have to say I'm not really finished with this experiment, and I wanna try to find the solution to keep it to obtain something a little bit more resistant. But this is the point, actually. Now, when we say that we want something more resistant, I always afraid that maybe are we doing something like the same mistake that we done in the past using the plastic? You know what I mean? So I would like to arrive in a certain point and say, okay, I like this material, but I don't want to have something that is too durable and too, you know, I would like to go back in the approach and say, okay, this is the material, these are the characteristics of the material. Let's do something that the material allows to do, you know? So this is exactly, I mean, this is the process that I'm trying to apply in my research, material research in general.
So I'd like to add another question to that. Maybe we can also open up the forum to everyone with this question, but maybe first Farah. This is, I guess, some really interesting point in methodologies and speculative design and biodesign. What you just said, Farah, that we come from the material and what we could do with the material. So in the case of algae and fungal material, I think in design industry, applicability and the use, the pure use, the pragmatic of use is so dominant. Yes. That it's probably very hard to rethink.
Yeah.
What do we all think here in our plenum today? What could the fungal material tell us? Would we use it as vessels? Would we think of clothes? Would we think of covering materials, or would we think of maybe growing materials, like in many of the fungi meetings and little symposia, we were very visionary, and we were thinking of growing architectural material.
Yeah.
Fungal material, what it could be. So I'd like to open up now maybe a discussion of how can we listen to the fungal material that might tell us how it would be ideally used and where.
Yeah. Well, actually, I want to go back at what just I told you. I think that first we should change the approach when we think about an object, when we think about an architecture, and when we think about an organism. We should not consider only the human being needs. No, we should not only think about from a human being perspective, but we should also learn about the organism, what the organism need to grow, the environment, and what we can learn from the organism. For example, I want to give you just an example why we don't increment, let's say, fungus into architectural facade, for example, and have something like I don't know, fungus facade for architecture, but at the same time we can use the fungus for mycelium, no? And then the mycelium, use the mycelium for producing the textile. So you see, in this way we really could have a kind of yeah, not really hierarchy, no, between humans and organisms, but really have a kind of sharing, collaboration, no, and respect the organism's environment and continue to keep our needs like eating, breathing, and wearing clothes, but with new materials, no. So I think this should be something that we can learn from the organism. Yeah. And I don't know.
Yeah, in the
Anyone?
Mind the Fungi project, we have very different approaches and different perspectives. And it's very nice to have those artists and designers in residence because they can be more speculative and more open to listen to the fungi. But at least they dry and powder and cook the fungus. So then it is not able to speak anymore, maybe. But in the Mind the Fungi project is just a start because we have many different ideas and different aims. One is Farah's developed material. One is like the things that Kushtim showed, like composites of solid plant mixed materials glued together by fungus. And like Kushtim said, in that direction, we try to optimize the material, and the material is not living anymore. It's dried and dead, and we think how to make it stable. So for architecture purposes, you need a material with reliable features and reliable material characteristics. And we try to, and the fungus is a living organism, and it behaves sometimes in a different way. And if you are not able to control all the conditions, then it might behave in different ways in different experiments. Then you don't have any reproducibility, and the material will be different at the end. But if you want to use it in a mass scale, so in the Mind the Fungi project, we also want to influence the big market. So we would like to have some materials which are used widely and can really replace, like a polystyrol, for example, which is a environmental unfriendly plastic stuff, and which is very similar to our composites in terms of density, mechanical force, which can withstand. And also heat transfer is similar. It's low. You can use it for insulation of buildings. And so we focus on getting it reproducible, getting it stable, getting the material properties stable, and then maybe produce or develop a product which is suitable for a big market. And then it's also an influence to the environment, because then we replace oil-based plastics with agricultural waste-based bio composites. So we have different foci. And another idea is to develop reactive materials, which may be still living. So the fungus, as you saw, the mycelium is a dense network of many very, very small fibers, and it's growing. If you see the Farah's biomats in the plastic boxes, they are still living, and they are a layer of very fine fibers, and that's very get very fast get the idea, why not using that for a kind of filter? Huh? And the fungus is reactive. Fungi in nature degrade organics which are hardly degradable, like wood. There's a reason why we have coal, for example, as fossil coal, which is fossil wood, because one way to explain it is in the area when coal was formed, there was no the fungi were not as active, so the dead wood could stay there and be covered by other layers of minerals and become wood. And if the fungi developed the right mechanisms to break down the wood material, then coal formation was stopped. But why I'm telling that? Yeah. So the idea is to develop reactive materials. And many of the pollutants that we produce in our economy are organic molecules, which are quite complicated and big. And many of the organisms outside have problems to degrade it. And that's the reason why we find them in the drinking water, for example, because they are alien to the living environment, and the bacteria and the fungi are not so easy to degrade it. And one idea is to grow a filter mat of living fungus and make it degrading hardly degradable organic pollutants, or maybe even influence the fungus to build very specific groups on the surface that some special molecules can bind very specific to the fungus. So yeah, there's many ideas, and the Mind the Fungi project was only 2 years, and maybe some months are left now. So it was just a start, and we have many directions, and we started many different things. We made a lot of contacts also to other specialists at TU Berlin and to many artists, many citizen scientists. Some of the citizen scientists from our courses joined our team and are now working. For example, Dimitra, she's working in our architecture team now. So that's very great. So we have a big network now, and the Mind the Fungi is just the start. And it's not possible to finish all the project and to answer all the questions. Maybe the 2 years was enough to start some things and finding some of the important questions.
Exactly.
Yeah. Okay, but
I see.
Thank you. I stopped talking.
Thank you. I see Valentina has another contribution.
Yes, I'm just trying to answer your open question. And I think one of the biggest challenge that we face in this biomaterial, biofabrication revolution is that sometimes people try to reach the plastic standards of the industry. And I think the interesting about biomaterials is exactly the unique and proper characteristics that these new materials have, and to try to enhance them. I think that's one of the biggest challenge in this revolution, and it's the beautiful particularity that this new material has. In Chile, for example, in the south of Chile, in our laboratory, we are trying to build and create a local material palette, and we're trying to identify the abundance of our territory to work with in the fungi, of course, world, but also in other kinds of industrial ways from our local territory. So I think that's important to understand for all the people that is trying to start this revolution, or they already started.
Yeah. Yeah, exactly. I'm definitely agree with you. We should look at the material itself and look also at to our needs, but I think we should find a balance, no, between what the material is able to give and what we can ask to the material. In my opinion, yeah, exactly. I'm totally agree with you, because then we could go again into this wrong direction that we had with plastic, no, and all of us to do everything using plastic. Yeah, even like something that is not supposed to live forever, like bags or tea brushes and this kind of things. Yeah.
Okay.
I have another suggestion, Farah. Today we're concentrating on one of your both residencies. So basically today we're speaking, and we have here Bertram and Kustrim and from the microbiology apartment, which has to do with microbiology and applied molecular biology. But there is also the bioprocessing part in the Institute of Biotechnology. And we have Zaki here with us. And this is also a part which keeps you busy at the bioprocessing department, that you work with liquid culture. And I wanted to ask you if you maybe could also shortly tell us something about that part. I'm sure our participants or out in the world, they might be also curious to know about that.
I'm not going to show what I'm doing exactly, so like the art piece I'm developing, but actually I would like to also just involve quickly Zaki to explain what means lichen, and what means when I say that I've been inspired from lichen because of the symbiotic relationship with between fungus and algae. So basically, I'm also doing another experiment to the biotechnology department, and I'm reproducing a co-cultivation protocol of about how to grow, co-cultivate at the same time algae and mycelium together in the same environment and using the same nutrients. Jackie, I think for sure she can explain much better than me. But basically what I'm doing is to reproduce this protocol and this co-cultivation process into an installation, art installation. And this is something that will be exposed to the next open of Futurium, official open, let's say big open of Futurium. And what is interesting from these experiments, from this co-cultivation process, yes, is interesting that you can grow and co-cultivate two different species, so algae and mycelium, but at the end you can also obtain a kind of biomass from this cultivation. And this is also an open question that I have, and I wanted to explore with this biomass, but unfortunately because of the corona, I've been forced to couldn't go further and experimented with biomass, because my idea was to know more about this material and see how we could use this biomass as new possible organic material. Yeah, but basically now maybe Kati can say something more about this protocol and experiment.
Yeah, maybe, yeah, as Farah told, my name is Zakiye. I'm also working in TU Berlin in the same project, Mind the Fungi. And until now, we could isolate the different partner from the lichens. We could isolate the algae and also the fungus from different lichens. Until now, there are 5 different lichens that we could isolate the both partner of them, and we are working on the cultivation of this both partner. And actually, until now, it was really good, and we could have much more than we thought the biomass from both of them. And we are now working on optimizing the culture and working with different media, as Bertram told, and we are testing which of them is better for fungi and which of them is better for the algae. And after we have the best growth media, we wanted to co-cultivate them. Actually, we are doing now, but the best is to know which of this media is better to have the best or more biomass of them. And until now, our work is here in this point.
And can you say which kind of fungus and algae do you combine together, you grow together?
Actually, they are from the lichens. Until now, we have the Gesantoria partina, and Gesantoria partina has this fungus as the fungus partner. The mycobiont is actually this Gesantoria partina, and the algae of Gesantoria is Terboxia. The name of species, actually, I don't know, but it's the Terboxia. Yeah,
it's a green algae, right?
Yes, exactly.
Okay.
It's unicellular. Yeah, it's algae, and yeah, we are working on both of them. And also the other is Lecanora muralis, is also the same fungus, and then another Terboxia with this species.
Okay, and have you had the possibility to watch the biomass this process, this co-cultivation produce?
Actually, as I told, we are now working on this, but I didn't measure that till now. But I have some idea which of the media is better, and then after that we have the dry mass, and then we can really say, because
yeah, because I think that at the moment you are not doing so much, no, right? I mean, the experiments are running.
Yeah, we have the permission, we can go some days, but not so exactly the experiments. Yeah, we are not able to do that.
Yeah, I know. I also was supposed to to continue, but
let's see, after that we can continue.
Yeah, for sure. Thank you. Okay, so
Are there any more questions? Maybe Farah, you have a question to us, or any more questions here in the plenum?
Well, actually, if I would like to ask you if there's something that you see, like, I mean, if there's something that you want to see from this workshop and you didn't actually, which was the expectation that you had from this workshop, for example, and because I see that most of you come from like art and design field, no? And I'm almost curious to know that you want to know more about let's say the approach, the collaboration, or you want to learn more the practice. So this.
I'm just reading a question here. Silvia has a question, and I'm reading it. Are there any ethical implications on using living beings into product design?
Yeah, this is an interesting question, because I have to say that so far I don't see any ethical implication, because we are still working, and I mean from scientists for sure, but from let's talk from the product design perspective. And I have to say that unfortunately I have to say there's not so much ethical implication, that we are still in this process, in this moment, that we want to use something, we want to produce something using organisms or living beings to satisfy our needs. But we are, I mean, yeah, I think that we are still into the wrong position when we talk about product design. And I can say that working as designer and artist in a biology department, microbiology department, you can learn a lot from this. I mean, yes, you can learn a lot from this ethical perspective and point of view. There's always a lot of questions about ethical implications, and looking at the behaviors of the microorganism, and understanding why they behave like this, and what we could do to improve something, no? So there's always kind of balance between the human, the scientist working, and the organism that is living and asking something. So I wish, no? Bertram, tell me if I'm wrong. But this is my perspective.
Well, don't say you are wrong, but we are still using the organisms and we're using the biomass, and we kill the organisms when we use the biomass. And I think it's the same with many other things, like wood, for example, like food, like vegetables. So it's the same. We are using organisms, living organisms, to to feed our needs, more or less.
Yeah, but I mean, you use them, but you also study and you try to respect also some aspects that the organism ask. No, you don't only destroy them.
The home of the fungi is the forest, and there they're living happily and killing trees. And I think that if we would ask them, they would decide to stay in the forest and not being studied and respected by us.
I know. I think you can be a good friend of.
I'm a friend of fungi, but I also eat them. Actually, there are many opinions to that thing. So, you said, "Oh, we are still in the wrong position." So that's actually a question: are we in the wrong position? What is the position of the human in the ecosphere? What is the position of one organism eating or using another one? And also, the fungi are behaving in different ways. there's a symbiosis between fungi and plants, which may turn into a kind of parasitism in both directions. Actually, there are fungi taking over the plant and eating the plant if the plant cannot deliver enough nutrients to the fungus. And there are also plants who harvest the fungal network and they don't do their own photosynthesis. They actually lost their photosynthesis capacity and only using the fungal network to get their resources. So it's in both directions. The symbiosis can turn into parasitism. So it's is that an ethical question too?
Yeah, but I think
it's a question. But is it ethical? So if we are animals in the ecosphere, should we also ask ethical questions to other animals? So it's a big topic.
And then also another question was, what are our reasonable needs? I would suggest we would take this discussion into our next workshop, because I just look on the clock and it's 8 p.m. So if I'm not mistaken, I look virtually into the round of our plenum. And so maybe I come to finish up with the workshop. So to the end of our workshop today, I first want to thank Farah very much. Thank you so much for your engagement today. Thank you for sharing accumulated knowledge with us.
Thank you
for presenting live the protocol with us. And thank you for the participants to be with us here in the Zoom. And I know that you all applied for an analog, real sur place workshop, and we hope we can repeat this or actually have it happen in the summer or autumn. But I think when we will be really sure to have it happen, talking about what humans are on the earth, what can we really do or what can we ask for? I think we are currently living in so interesting times. I think we should be humble, and I think we should really have a lot of patience. And we can be happy that we had the technical possibility, more or sometimes less today, to follow each other. So I want to say, we cannot promise anything, but somehow in the future, I'm sure we have the real local workshop having happen. So to also finish up, I want to thank very much Bertram and Kustrin to share your knowledge with us in a very dense form. And I want to thank everyone out there who followed our live streaming on the Art Laboratory Berlin website. It was very enriching to share this today with you on a very impromptu, somehow also like from the technical side, improvised way, but that makes us all maybe, that puts us in a place that we're just restricted in the way humans can only act. So it's always like a humble try that we can come together as much as we want. To wind everything up today, I also have some invitations for you. As we mentioned already, Maite Fungi is currently present at the Futurium. This is the house of the future, and there is a Futurium lab in the underground of this new building that opened their doors last September. And Chris and me from Art Laboratory Berlin, we were invited to curate Maite Fungi there. So currently there's the first exhibition there. Futurium is closed. They will open their doors, but for the upstairs exhibition from 13th of May on. I heard in July they will open the Futurium lab. Then the first show will be taken down, and then this is what I want to announce. We are curating a show with Farah and Teresa to show works in art and design about Maite Fungi. And we're also happy to show bioblocks and objects from the Department of Applied Molecular and Microbiology, where Bertram and Kustrim and other colleagues are coming from, and also from the bioprocessing, where Zaki is based. So in other words, we have a second show at Futurium. opening up early July, and it ends at the end of this year. So we're very sure that we all could maybe meet there, or you can all have a closer look. And also then we can be very, very excited to see haptic objects and works by Farah. So this is what I wanted to say from my side. For everyone inside and outside, I want to thank you for the attention and your interest. If you want to follow Art Laboratory Berlin and you're not in our newsletter, send us an email and follow us. You can also follow us on Facebook. And for now, we just say goodbye and hope to see you soon again. Thank you very much for your engagement and your interest.
Thank you very much to everyone for being here. Thank you.
Thank you.
Bye bye.
Thank you very much. Bye.
Thank you.
Bye.